This video is about solving systems of equations with elimination. Now, in this type of problem, the goal is to find the values of x and y that satisfy this system. This is x plus 4y equals 8 and 3x minus 4y equals 8. There's one x value and one y value that should satisfy this system. So the thing to remember for elimination is in order to eliminate, we need to create or find a pair of opposites. We need to create or find a pair of opposites. So, for example, easy example, the opposite of 3 is -3. When you add 3 to -3, they cancel each other out, you get 0. The same thing applies for variables. Let's say I've got positive 5y. The opposite of positive 5y is -5y. Add them together, you get 0. 0y. They're gone. So let's apply this to this system over here. I'm already seeing in my system, I've got a pair of opposites already. This is positive 4y in the top equation and -4y in the bottom. So here's how we eliminate these. We need to eliminate the y's so that we can solve for x. Otherwise, we don't really know how to solve equations with multiple variables in them. So let's treat this like a big addition problem. Let's go ahead and add, starting on the right side like we normally do, 8 plus 8 is 16. And then we have positive 4y plus -4y. That cancels out. That's gone. I'm not even going to write it here. And then we have 1x plus 3x. That's 4x. So now we have a much simpler situation to handle here. We have 4 times x equals 16. And so to solve for x, we divide both sides by 4. And then we get x equals 4. So that's part of our problem done. We've solved for x. Now we need to go back and solve for y. This is where our problem becomes really similar to our substitution method. So using x equals 4, we're going to plug that into one of the two equations. I'm going to choose the top one just to make it easy. So here it is. It's x plus 4y equals 8. And x is 4. So we replace x with 4 and rewrite the equation. So to solve this equation, to solve for y, we subtract 4 from both sides of the equal sign. Then we have positive 4y equals positive 4. Then we're going to divide both sides by 4. And you get y equals 1. So now we've solved for x, we solved for y, and our final answer is x is 4, y is 1. This is the coordinate that satisfies both equations in the system. Let's go ahead and try another one. This one's a little bit different. Okay, so now we have 2x minus y equals 20, and we have 3x plus 2y equals 19. You might notice that there's no longer a visible pair of opposites. We're going to need to create that pair of opposites by multiplying one of the equations by a number. So right now I see positive 2x and positive 3x. There's not really any way we can multiply our equations in an easy way to get a pair of opposites here. What about -1y, this is -1 here, and positive 2y? I think we could multiply this top equation by 2 so that this could become -2y, create a pair of opposites here. So let's do that. We're taking this whole equation, the whole thing, multiplying by 2. And so I'm going to write it down on the bottom here. I'm going to have Well, 2x times 2 is 4x. Minus, well, 1y times 2 is 2y. Equals, and then 20 times 2 is 40. So now we've got this system. The only thing I changed was the top equation. I multiplied the whole thing by 2. We can still solve the system of equations this way. All right, here's my pair of opposites. I'm going to eliminate my y's again. Okay, again, treat this like a big addition problem. 19 plus 40 equals 59. Positive 2y minus 2y cancels out. And then you're left with 3x plus 4x, which is 7x. So this problem's a little uglier. We're going to divide both sides by 7. And then x equals 59 over 7. From here, we could plug this in to one of the equations. I want to show you something with the top equation. Let's say we wanted to plug in 59 over 7 into the top equation. You can plug it into the original or into the multiplied one. It doesn't matter. But I'm actually going to plug in 59 over 7 into the original. So here's what that looks like. Let's rewrite it. 2x minus y equals 20. Okay, so now we need to plug in 59 over 7. Okay, 2 times 59 over 7. Man, this is not working out very neatly. You've got 118 over 7 minus y. And then just to make things a little easier for me here, I'm going to multiply the top and bottom of this by 7 over 7, just to make it easier to add subtract here. So I've got 140 over 7 on this side. Now to cancel this out, I'm going to subtract 118 over 7 from both sides. And then you get negative y equals 22 over 7. There you go. Now we're not solved for y yet. We need to actually change signs here. So in order to make y positive, we need to change the sign of the terms on the right side of the equal sign. So y equals negative 22 over 7. That was a doozy. But you have your final answer here. And so our final answer, the values of x and y that satisfy this system of equations is 59 over 7. You could write this as a mixed number if you really wanted to. And negative 22 over 7. And there you have it.